How's everybody doing? So this is going to be a big, complicated video. We're going to bring this thing all together. So far we started out and we said, okay, what do we need the robot, the hovercraft to do, the motors to do when we use the joystick? So when we push the joystick forward, we said, hey, we needed both motors to be at the same positive speed the whole time. That'll get it going forward. If we want to pull the joystick backwards, we want both motors to push backwards on the motor, negative speeds on the motors, and be the same. If we go straight to the right, we want the left motor to be positive and the right motor to be negative, but the same values, so it can just sit and spin in one place. Same thing for the left spin here. And then up here we said, okay, the left motor to be going right and turning right, to be going forward while turning right, we need the left motor to be greater than the right motor. And over here, the opposite, left motor less than the right motor. So these tell us kind of what the motor speed should be in general to make the hovercraft turn and drive the way we want it to. Then we said, okay, we need the motors to do that, but what data do we get from the joystick? So down here is our joystick data. So when we push the joystick forward, we get a y-axis value of plus 100 and an x value of 0. And we went all the way around and figured out all what our joystick tells us. Now we need to do the hard work of taking that joystick data down here and mapping it or combining it in such a way that we get left and right motors that work for this stuff. And that's what we're doing today. It's going to be heady, it's going to be tricky, so get to a point where, or a place where your mind is focused. You can get some headphones on so you can really listen and focus on what we're doing next. All right, so we're just going to try some stuff. So the first thing we might want to do is, hey, we have two motors and we have two axes. What if we just map the left motor to the y-axis and the right motor to the x-axis? Let's see if that works. So over here, I'm going to say the left motor, and I'm going to say, let's just make it equal the y-axis. Heck, that seems super easy, and why not try the easy stuff first? So left motor is y-axis, Control C. I'm going to paste that down here. Whoop. I'm going to paste that down here, and I'm going to call this one the right motor, and we're going to say, let's just map that one to the x-axis. Let's see what that does. Maybe it works, maybe it doesn't. Okay, so first thing I notice is in this box, if I do this, if I say the left motor, so I'm going to record here what my left motor commands are going to be. It's going to be 100 because the y-axis is 100, so this is going to be positive 100. And then the right motor is the map to the x-axis, and it's at 0, so it's going to be 0. Awesome. Now I'm going to check this. Did this mapping, did this rules I created right here, did that create rules or motor speeds that work up here? And right away I can see it doesn't, because here we need our left and right motors to be the same positive number. And if we use this mapping protocol where the y-axis is the left motor and the x is the right motor, we get a 100, 0. That is not the same. Okay, great. That won't work, so let's do something else. We need to, the simplest thing was just to map each motor to different axes won't give us what we want, so I'm going to delete this. What if we do the y-axis? I'm going to put it in parentheses so we can see it a little easier. So what if we take the data from the y-axis and we add it to the x-axis? I mean, adding is the next easiest thing to do in life, right? So we add those two together to get a number. And then let's do the same thing for the right motor. So I'm going to copy and paste that down here. So we'll do the left motor, we'll just add the two axes together for the value of the left motor, and do the same thing for the right motor. All right, let's do this first one again. Let's say y-axis plus x-axis. Well, in this position, the x and y, the y is 100, the x is 0. 100 plus 0 is 100. So positive 100. And the right motor would be the same thing, so positive 100 plus 0 is positive 100. And that works, because notice we want them both to be the same and both positive. They are the same and both positive. Woohoo! So this protocol gives us reasonable results for a straightforward stick. Awesome. So now let's do the next one, which is this one. And this one we want the left motor to be positive and bigger than the right motor. and we don't care if the right motor is negative or 0 as long as it's smaller than the left motor. All right, let's do the math now. So we said our left motor is y-axis plus x-axis. So over here we do the y-axis of 70 plus the x-axis of 70, and we get positive 140. Now right away that feels weird because that's 140% motor speed. And that might cause us problems to tell the motor to go faster than what it can go, because the signal to make it go faster might make the motor like be out of phase and out of tune. But we can solve this with code. We can write a little piece of code that right before we send the motor speed to the motor, we say, hey, if the motor speed is more than 100, make the motor speed back to 100. So we can create kind of a cap in the code with just an if statement. So we'll do that later if we need to. All right, so this is weird, but not a really big problem. The left motor is still super fast positive. That's what we want. And now let's do the math for the right motor. So we said right motor is y-axis plus x-axis. So that's going to be 70 plus 70 again. So that's a plus 140. And right away we see, oh wait, this isn't going to work because the right motor needs to be less than the left motor. And this is not what's happening. So this protocol worked for the straight up, but didn't work for our right turn. All right. So the next thing to try, I don't know, it looks kind of like the left and right motor are opposite each other. Like when one gets big, the other gets small. So maybe what we do is we subtract one of them. So let's say we subtract this one. I don't know, maybe the left motor. Let's try to subtract the left motor. So let's make this one y-axis minus x-axis so that they're doing opposite stuff. Okay, let's go back and recheck our first box real quick. So y minus x is 100 minus 0, which is 100, yay. And we know this one's right because it's 100 plus 0, so that still works. And now our left axis would be y-axis minus x. So y-x-axis minus x, so 70 minus 70. That would make our left motor 0. And our right motor would be y plus x, 70 plus 70, 140. Okay, that would be this one. But that gave us left motor should be greater than right motor. Oh, the left motor is less than right motor, so that didn't work. But it did kind of work, but it's kind of backwards. So what if we do, and we're just trying stuff, so what if we made this one, keep this one as the positive one, and make this one minus? That's going to make, so let's redo this one real quick. So x plus y, so that makes this one the 140. And then we're going to do the right motor is y minus x, which is 70 minus 70 is 0. Ooh, that's interesting. So now we have a left motor. Let's check it up here. So we have a left motor that's bigger than the right motor, which we wanted, and the left motor is positive. What? All right, so taking the left motor and adding the axes, and then the right motor subtracting the axes has given us two boxes that work. Let's try this one now. So we're going to come to this box, and I'm going to say, okay, and the left motor is the y-axis plus the x-axis. So down here, my left motor is the y-axis 0 plus 100 is 100. That works. And then the next one, the right motor says it's y-axis minus x-axis. So now we've got to be careful with sign here. So the y is 0, so it's 0 minus 100, which gives us negative 100. Ooh, that looks funky. Let's check it. So over here we said we want our left motor to be positive and equal to the right motor but negative. Ooh, and we have that. We have the left and right motor the same value, but the left is positive and the right is negative. Oh, snap. So these two rules tend to work in these three boxes. I wonder if they'll work in all the other ones. So here's what I want you to do at this point. Go through the other boxes and type in all of the values, calculate all the values that we would get in all those boxes, and see if they correspond and all of these stay true all the way around. I'll do the same thing, and then when you're ready, start playing the video again, and I'll show you the answers to it, and let's see if this works. So go ahead and pause the video now. All right, we're back. I've done the math here, and these are the numbers you get, and they look pretty good because there's just like these weird patterns to them that kind of make sense. So I think we might have something that works really well, and they match our rules here. So left motor less than positive right motor, this left motor is less than the positive right motor. So I think we might have it. So when we do our math now, in our program, we're going to need to take the value of the y-axis plus the value of x-axis and then send that to the left motor with this little caveat that if it's greater than 100, we bring it back to 100. So yeah, we've got a plan. Good job today. Hang in there. If you've got questions, ask. I'm here to help.